So solving systems of equations by substitution. First, we're just going to talk about what systems of equations are. So system of equations is when we have two equations that both have two variables. Okay? So if I have something like y equals 2x minus 3 and y equals 4x plus 7. These together make a system of equations. Okay. So a system Well, that was fun, all the squeaking away. The system of equations is when we have more than one equation and more than one variable. So in this case, we have two equations and two variables, y and x. This would be called a 2-by-2 system. And we're going to work exclusively with 2-by-2 systems. So you're always going to have two equations and two variables. Now, it does not mean that you can't have that you have to have two variables in both equations. So this would be another system of equations. Y equals 5 and x plus y equals 10. This is also a system of equations. I have two equations and I have two variables. But the first equation only has one variable. It doesn't matter, I have two variables total. Now, what is an equation called when it has two variables? We've been working on this. If we have x's and y's, that's called a linear equation. This is a line on a graph. And you guys actually know how to graph it. So is this. This is also a line. Y equals 5. There's just a line going straight across the graph horizontally up at y equals 5. And this is also a line. All of these are lines. Okay. So, markers are not cooperating today. So we have systems of equations. I'm going to put something on the board. I'm just going to ask you, is this a system of equations? Okay. Is this a system of equations? No. What is that, in fact?
That is a
variable.
Yeah, this is just a one variable equation. What would you do with that?
Minus 7.
Yeah, you would subtract 7 and find out what x
It
equals.
said x
X
equals 3.
equals 3. No.
Okay. Is this a system of equations? Is that a system of equations?
Yes, it is. Yes. No.
Wait.
No, because if you use for
No, it's not.
No. I only have one equation.
Then up to.
I do now have two variables, so I'm getting closer. What would you do with this?
You would use it for a graph.
Yeah, you would graph this. This is a line on a graph.
I know this.
Okay.
You go up.
How about
You go up 5 and over 1.
how about
You
this?
go up 3.
And then 2 more, so 5. Guys.
Oh.
Minus
Is
1.
this a system of equations?
No. No, it's you minus 1 and then you x.
Come on, Nate.
Okay, how about
Yeah,
this
that's
one?
the same answer as the last one. 3.
That is a. Wait. No, never mind.
Is this a system of equations?
Yeah.
this is.
I don't know why, but yes.
This is a system of equations because we have more than one equation
Oh.
and we have more than one variable.
And they all have to be
Okay,
the same.
so remember, each one of these equations is a line. So like in this case, I'm just going to roughly sketch this. We have a line that goes like this, and then we have another line that goes like this. Right? Those are kind of my lines in this case.
It's straight line, right?
Those are parallel.
Ish.
Now, when we solve a system of equations, I'm going to show you exactly what we're looking for. Let's say we had the equation y equals x minus 1 and the equation y equals negative 2x plus 2. Okay, we could graph those. Go down 1 and go up 1 over 1. We'd have one line going like this, and then we'd have a line going like this. 1, 2, and go down 2 over 2.
So we're going to have
Oh.
two lines.
Yeah, but we're not going to do this.
Oh.
I'm just explaining what a system of equations is.
I can do that.
So I have two lines. The reason we solve systems of equations is because we want to know where do those two lines cross each other.
So we're going to find out.
Where do they intersect? And so we're going to find this point. Today I'm going to show you one way of finding this point. Although technically I've shown you one already, which is you could graph the lines and find the point.
Oh, yeah.
But that's not what we're going to do for today. Because this can be really hard. It doesn't always work out very well. So today what we're going to do is called substitution. So what I want you to remember though, a system of equations is more than one equation with more than one variable. It represents two lines on a graph, and we're looking for the point where those two lines intersect. Because when you solve them, it's not going to, all of that is going to seem kind of irrelevant. But it's important to have that in the back of your mind. So let's say I gave you these two equations. Y equals 10 and x plus y equals 20. The way we're going to solve this is called substitution. Do you guys agree that y is 10? So in this equation, when I see y, I'm just going to write 10. So now I'm going to write x plus 10 equals 20. Now I can actually solve that, because I did this one step of substituting 10 in for y. X plus 10 equals 20, so what does x equal then? Subtract 10 from both sides. X would equal 10. Okay, now the trick with a system of equations, remember, we're looking for a point where two lines intersect. So your answer is always going to be a point, x, comma, y. We found x is 10, and y was kind of given to us in this one. Y is 10. So this is the answer to this system of equations.
And how would you graph that? Well, oh wait, no.
We're not graphing anything.
Okay.
Okay? You could graph these, and the point where they intersected, right? You'd have like,
Would be 10,
two lines going like this. The point where they hit would be 10, 10. Which, if you think about most graphs that we make, that probably wouldn't work out too well for us.
Yeah.
Because usually 10, 10 is like way on the upper corner of our graph. So seeing the two lines intersecting there would be pretty hard. But, so let's do another one. What if I said y equals 3 and x minus y equals 4?
So it would be x minus
Yeah, so y is 3. So I'm going to substitute that in here. X minus, and I want you to get used to putting parentheses around whatever you substitute in. Now in this case, the parentheses don't really do anything. We just have x minus 3 equals 4. So I can kind of ignore them. But I still want you to write them in. X minus 3 equals 4. So I'm going to add what to both sides?
3.
Add
And
3 to both sides. And x will equal
Equals
7. Am I done?
Nope.
So my point is going to be x, comma, y. 7, comma 3. It's always alphabetical order.
Its own number that's making it is also going with it.
Now,
We helped make it. So
This is easy.
now some of these are going to be a little bit more complicated.
it came back from the dead.
So
Show
what
us.
if I had something like this? Y equals x plus 1. And then down here, I had x plus y equals 11.
Oh, let's do this.
So we have to find y.
Yeah, I can still do the same thing. I have y equals x plus 1, and I have a y down here. So I'm just going to substitute this in. X plus 1 equals 1. Okay, now I've got to remember about combining like terms. First of all, the parentheses don't do anything here because this is a plus. There's nothing to distribute. So I can just go x plus 1 equals 11. What is x plus x?
2x.
2x. So 2x plus 1 equals 11. Now I subtract 1 from both sides. 2x equals 11 minus 1 is 10. Divide both sides by 2. X equals 5. Now, the problem is I don't have y yet. But I know y is x plus 1. So I'm just going to take this and now plug it back in here. Y equals 5 plus 1. So y would equal 6.
How did you get the y equals 5 plus 1 though?
Because x is 5.
Oh, so you're going to add that with...
I'm not adding anything, I'm just plugging, oops. So x comma y is going to be
So you're going to add
5 comma 6.
5 plus 1. Oh, I see how that works. Is that
So when I
always the
get
case?
my x,
This is the harder.
I have to now find y.
This is always the case.
Well, it won't always be exactly the same, but you will always have to find the second variable. Okay, they didn't give it to you. So there's like kind of an extra step at the end.
Okay.
Once I found x by solving this, I didn't know y, but I knew that y was x plus 1. So if x is 5, y has to be 6. Right?
Do you have to use the parentheses?
Yeah, and let me show you what. So make sure you're writing every example down in your notes. So what if I had something like this? Y equals x plus 3. And then I had like x plus 2y equals 21.
So,
Okay.
don't
So I know y is x plus 3. So I'm going to rewrite this x plus 2. And this is why you have to have your parentheses. Because the 2 is going to distribute to the x and the 3. Okay. So what I have here is x plus 2x plus 2 times 3 is 6 equals 21. What is x plus 2x?
3x.
Yeah. 3x plus 6 equals 21. How do I solve that for x?
You subtract 6.
Subtract 6 from both sides.
That's supposed to be 3x equals 12. Wait, 14.
15. Divide both sides by 3. And x
15.
equals, what is 15 divided by 3?
Wait, hold
5. Okay?
So it would be y.
on. I don't get it.
Now-
26
Y equals
minus
5
20.
21 minus 6.
21. I put 20.
Oh, that's why. Okay. Now I need to find y. So I put this back in here for x. Y equals 5 plus 3. Y equals 8. And this second step is usually going to be easier, especially when we're doing substitution. The second step is just going to basically be adding.
So all we have to find is just the parentheses thingy.
So now we need to say
So
x is 5, y is 8.
Is that all we need in our answers though?
So that's your answer right there.
Wait, I gotta go.
Oh.
Let's do another one like this, and I'm going to throw in a little bit of a trick now. But you guys can handle this, I think. So what if I had something like this? Okay, x equals 2 y plus 4. And then what if I had, let's say, y minus 2x equals, are you guys okay? Can you handle this? Alright, equals 28.
So it would be y.
So now, there's one little thing that's different right away.
Yeah, the 2x.
I know x now, not y. But that's okay. I can substitute for x just as easily as I could substitute for y. So I'm going to put this in for x here.
Oh.
Y minus 2 times 2y plus 4 equals 28. Okay. It's not really any different. I'm just substituting for x instead of for y.
It looks a lot.
Why did I do that? Why didn't I substitute for y? Yeah, it didn't say y equals. It told me x equals. So I plugged that, what x equals in. So whatever they give me is what I'm going to plug in here. Okay, so now I have to distribute. Remember to distribute the negative. So we have y minus, so minus 2 times 2y is minus 4y. And then negative 2 times positive 4 minus 8 equals 28. What is y minus 4y? Negative 3y minus 8 is 28. I'm going to add 8 to both sides. So I have negative 3y, because those cancel out, equals 36. Divide both sides by negative 3. Those cancel. I just have y equals, what is 36 divided by negative 3? What is 36 divided by negative 3?
Negative.
Negative 12.
8. Oh.
Oh,
Now,
yeah.
like Lucas said, there's no x. I have to go find my x.
We need x.
So if y is negative 12, that means that x is 2 times negative 12 plus 4.
Wait, where'd you get plus 4? Oh.
Because it was there. Which means that x is 2 times negative 12 is negative 24 plus 4. X is negative. And then I'm ready to write it. X is negative 20. Y was negative 12. And I have my final answer. So the math was a little harder in this one. We were dealing with negatives and some bigger numbers. But the steps were the same.
That is a lot of work.
So just pay close attention, right? When you start to see negatives and bigger numbers, you have to kind of cue yourself in. I'm going to double check my work on these.
Oh, that's a lot of work.
Because I know that this is a negative number. So I'm going to just look one more time at this. 36 divided by negative 3. Okay, positive divided by a negative is a
Negative.
negative. 36 divided by 3 is 12. Okay, I'm just checking that that made sense. I'm going to check my work up here. Y was negative 12. Okay, I put that in correctly there. X is 2 times negative 12 plus 4. Okay, I copied that all down right. X is 2 times negative 12 is negative 24. Okay, adding 4. Okay, negative 24, and then I'm adding 4. So that would get me to negative 20. And just think about each problem kind of an extra time when you start to see bigger numbers and negatives. Check your work in that way. And that is your final answer.
Yay.
So that is substitution. And that's what we're going to do for today.
Now homework.
So your homework will be this, and it will also have a little bit of graphing review.